Just off Naples, the sea is boiling. Strange bubbles rising, a deep rumble echoing beneath the waves. Scientists have confirmed it. These are fresh warnings from Campi Flegrei, the restless supervolcano feared to be awakening under 3 million people. The last time the Earth trembled like this, the coast was reshaped forever. But what exactly is happening beneath these waters, and could history be repeating itself right now? Fishermen from Pozzuoli and Bagnoli wake before dawn, steering their small boats into the bay as they have for generations. But this autumn, their routine is interrupted by something they cannot explain. A patch of sea, usually calm and glassy, now churns with bubbles. The water shivers and ripples, disturbed from below. At first, some think it's just a school of fish or a passing current, but the bubbling spreads, wide, insistent, and unbroken. The sound is not like anything they remember. A low, steady rumble, deep enough to vibrate the hulls of their boats and echo in their bones. Word travels quickly along the docks. Videos shot on shaky phones show plumes of gas breaking the surface, white foam swirling in unnatural patterns. Fishermen speak in hushed voices about the strange, sharp smell drifting across the water, sulfur, and something metallic, stinging the nose. Some recall stories from their fathers and grandfathers, tales of fish dying suddenly, and the sea turning wild before the ground itself moved. Social media fills with clips of the bubbling patches, tagged with exact GPS coordinates. Locals gather along the seawall, pointing at the shimmering water. One fisherman, Giovanni, describes how the bubbling grew so intense that his boat rocked in place, as though something enormous was breathing just beneath him. Another, Salvatore, says he's seen the sea do strange things in storms, but never under a clear sky. Never without wind. The unease speed is palpable. Fishermen who normally brave any weather now hesitate to cross certain parts of the bay. Community leaders, alarmed by the mounting anxiety, call for an official inspection. Port authorities and local politicians arrive, capturing footage and collecting water samples. The beach at Bagnoli is cordoned off in places, swimmers warned to stay away from the most active bubbling zones. The spectacle draws crowds, but the mood is far from festive. Many speak of the ground beneath the bay as alive, unpredictable, and growing restless. For those whose livelihoods depend on these waters, the bubbling is more than a curiosity. It's a warning they cannot ignore. Each new patch, each fresh surge of gas, sends a ripple of worry through the fishing community. What once felt familiar now seems uncertain, as if the sea itself is trying to send a message from the depths. INGV technicians arrive at dawn, carrying metal cases and bundled cables down the dock. Their first priority is safety. A cordon stretches along the most active stretch of beach, and warning signs keep the curious at bay. The team moves quickly, assembling gas traps and lowering temperature probes into the churning water. Every reading is logged in real time. The bubbling is not random. It clusters along a newly mapped line of vents, some less than 20 meters from shore. Instruments record sharp spikes in carbon dioxide and sulfur dioxide. In several spots, gas concentrations reach levels that would be dangerous to breathe, confirming that these are volcanic emissions, not the work of decaying seaweed or industrial runoff. Remote-operated vehicles glide beneath the surface, guided by fiber optic tethers. Their cameras reveal a pockmarked seabed, each vent ringed with yellow and white mineral deposits. Some orifices spit out bubbles in rapid bursts, others in steady streams. The water above these vents shimmers, but temperature sensors show only a modest rise, less than 1 degree Celsius in most places, sometimes higher right at the vent mouth. The effect is dramatic to the eye, but the real story is chemical. Gas samples pulled from the water column show CO2 levels far above background, along with traces of hydrogen sulfide and methane. Oxygen drops sharply near the vents, and pH readings confirm a surge in acidity. The team overlays these findings with recent satellite data. Thermal imagery from above matches the vent fields mapped by ROVs below, confirming that the bubbling is not a surface illusion, but a direct result of volcanic degassing. Sonar and bathymetric surveys add a final layer. The seafloor here is not static. It has lifted measurably since the last survey, pushing new cracks and fissures into the overlying sediments. Each patch of bubbling water is now a data point, proof that the ground beneath the bay is not just restless, but actively changing. INGV's official report leaves little doubt. The anomaly is volcanic, and it is accelerating. The hazard is no longer just a rumor among fishermen. It is measured, mapped, and verified, with every new reading tightening the focus on what lies beneath. Campi Flegrei is not a single mountain or cone, but a vast underground world stretching beneath the western edge of Naples and out under the Bay of Pozzuoli. Its caldera, a collapsed volcanic basin, spans nearly 13 kilometers, large enough to swallow the entire city center and its suburbs. The real volcano is mostly hidden, a landscape of parks, neighborhoods, and harbors built atop a restless, shifting crust. More than 3 million people live within reach of its influence, many unaware that their homes sit above one of Earth's most complex volcanic systems. The ground here does not simply rise or fall, it breathes. This slow, rhythmic movement, bradyseism, has pushed some districts upward by over 4 meters since the 1950s. Ancient Roman columns at the Serapeum in Pozzuoli still bear the scars. Their bases, once submerged, now high and dry, banded with lines where shellfish once clung. Streets crack and tilt, buildings lean at odd angles, and new patches of land appear where water once stood. For scientists, these changes are not just oddities, they are clues. Dr. Giuseppe De Natale, a senior researcher with the INGV, has spent decades mapping the anatomy of this caldera. He describes Campi Flegrei as a layered system, a shallow cap of clay and altered rock, beneath which lies a pressurized pocket of steam and gas, and deeper still, a vast chamber of partially molten rock. This hidden architecture has been revealed through seismic tomography and muography, techniques that use earthquakes and cosmic rays to create images of the subsurface. Much like a medical scan for the planet, these scans show zones of low seismic velocity and high electrical conductivity, clear signs of hot fluids, and melt. The data confirm what ground movement and gas readings suggest. The system is active, and its pressure is building. The most recent surveys reveal that the shallowest parts of the caldera, just a few hundred meters below the surface, are dominated by a steam-rich reservoir. This is capped by a thick, clay-rich seal that traps gases until they find an escape route, often through sudden cracks or vent openings, like those now bubbling off Bagnoli. Below this, at depths of 2 to 4 kilometers, sits a hotter, more volatile zone, where temperatures soar above 600 degrees Celsius, and pockets of magma mingle with superheated water. At the greatest depths, 6 to 8 kilometers down, a partially molten mush zone acts as the engine feeding heat and fluids upward. Each layer has its own role in the system's breathing. When fluids or magma accumulate beneath the cap, pressure mounts and the ground swells. If the seal weakens or cracks, gas escapes, the pressure drops, and the surface may subside. These cycles have repeated for centuries, but recent imaging shows more melt and more open pathways than in previous decades. The risk is not just theoretical. With so many people living above this dynamic system, even small changes can have immediate consequences. Cracked roads, damaged buildings, and, in the worst case, sudden eruptions. Dr. De Natale cautions that the caldera's true danger lies in its shallow depth. Unlike classic volcanoes, where magma must force its way up through kilometers of solid rock, here, the pathway is shorter and the cap thinner. This means warning times can be brief, and surface effects, like the bubbling sea, can appear suddenly. The ground that breathes is also ground that can break. Every new vent, every patch of uplift, is a reminder that the hazard is both real and immediate, mapped not just in scientific charts, but in the daily lives of millions. By the spring of 2025, the numbers coming in from Campi Flegrei's monitoring networks no longer fit the old patterns. Ground sensors at Pozzuoli and Bagnoli log more than 15 centimeters of uplift in less than a year, faster than any Brady seismic episode since the 1980s. Satellite radar, using INSAR, confirms a dome-shaped bulge centered beneath the bay, matching the areas where new vents have cracked open. GPS stations, anchored to ancient stone and modern rooftops, show the same relentless upward push, with the land rising at rates that once would have triggered alarm on their own. But the ground is not the only thing shifting. Seismographs scattered across the caldera pick up a steady drumbeat of earthquakes, sometimes hundreds in a single month. Most are too small to feel, but their depth is what matters. Recent swarms cluster at less than 3 kilometers below the surface, much shallower than in previous years. This is the danger zone, the brittle crust just above the pressurized reservoir. Each swarm follows the same pattern: bursts of quakes that migrate upward then fade, only to return days or weeks later, always a little closer to the surface. At the same time, gas emissions surge. Field teams record carbon dioxide and sulfur dioxide pouring from fumaroles at Solfatara, Pisciarelli, and now the new offshore vents. Instruments measure spikes in gas flux, sometimes more than double the long-term average. These gases are not just leaking from the surface, they are being forced out by pressure from below, evidence that something deep in the system is stirring. Air samples collected near the bubbling sea show concentrations high enough to warrant exclusion zones. The chemistry points to a magmatic source, not just shallow hydrothermal fluids. Dr. Christopher Kilburn, a volcanologist at University College London, studies these converging signals with growing concern. For years, he has warned that repeated cycles of uplift and subsidence weaken the caldera's crust, lowering the threshold for rupture. His models show that every centimeter of new uplift, every shallow quake, every surge of gas brings the system closer to a critical point. Kilburn calls this the ticking clock, not a countdown to a known deadline, but a rising probability that the next trigger could set off something larger. He points out that in volcanic systems like Campi Flegrei, it is the combination of signals that matters. Ground deformation, gas, and seismicity alone can be explained away. But when all three accelerate together, the risk compounds. The consensus among monitoring teams is sobering. Campi Flegrei is far from quiet. The pace of ground movement, the shallowing of earthquake swarms, and the surge in gas emissions have never before aligned so clearly in the modern monitoring era. Each metric on its own would demand attention. Together, they justify the heightened concern now gripping both scientists and civil authorities. The data leave little doubt. The caldera is restless, and the warning signs are converging. In October of 1538, the fields and villages west of Naples began to tremble. Letters from that autumn describe the earth swelling and splitting open, with cold springs turning suddenly hot and clouds of white vapor rising from the ground. Within days, water in the marshes and along the shore started to bubble and steam, forcing families to flee, as the air filled with a sharp, sulfurous haze. The upheaval did not unfold over months or weeks, but in a handful of nights. On the morning of September 29th, the first fractures appeared near Lake Avernus. By October 4th, a new volcanic cone, Monte Nuovo, had thrust itself 123 meters above the plain, burying farms and swallowing part of the coastline. The eruption was violent, driven not by slow rivers of lava, but by the sudden conversion of groundwater to steam. Witnesses reported the ground heaving, fountains of boiling water and mud, and a deafening roar as rocks and ash rained down. The coastline itself shifted, with entire stretches of land rising out of the sea. Some of the most vivid accounts come from local priests and notaries, whose words survive in archives. The earth opened with a terrible sound, water boiled furiously, and clouds of vapor blotted out the sun. Modern seismologists have studied the blast mechanics of Monte Nuovo, tracing the eruption to a shallow reservoir of superheated water and gas trapped beneath a clay-rich cap. When pressure broke the seal, the result was a hydrothermal explosion, one of the most dangerous forms of volcanic activity. Unlike lava flows, these blasts can hurl blocks and ash at hundreds of kilometers per hour, flattening everything in their path. Geophysical surveys suggest that the same deep conduits which fed Monte Nuovo still connect the caldera to the sea, and possibly, through hidden channels, to the magma systems of Vesuvius. The parallels to today's unrest are not lost on scientists. Dr. Giuseppe De Natale notes, "What happened in 1538 was not a slow buildup, but a rapid sequence of events. The warning signs, uplift, boiling water, gas, are the same ones we monitor now. The lesson is clear. When land and sea both begin to breathe, the clock can move quickly from warning to disaster." Civil Protection Headquarters in Naples is never quiet. But since the first reports of the bubbling sea, the pace has changed. Phones ring with updates from INGV, and screens flicker with real-time feeds from seismic sensors and gas monitors scattered across the bay. The official alert level remains at yellow, attention, not alarm, but the protocols are in motion all the same. Teams review evacuation maps, checklists grow longer, and municipal workers test the emergency sirens that dot the neighborhoods of Pozzuoli and Bagnoli. Every few weeks, the wail of a practice alert echoes through the narrow streets, a sound that unsettles even those who have lived here all their lives. At a recent community meeting, a civil protection official stands before a crowded hall answering questions about what the yellow alert really means. He explains that the region has lived with risk for generations, but now, with the bubbling sea and the surge in ground movement, preparations are more than routine. He describes enhanced surveillance, new exclusion zones along the waterfront, and regular drills for schools and hospitals. The message is clear. There is no cause for panic, but everyone must know what to do if the situation changes. The Di Martino family, 3 generations under one roof in the old quarter of Pozzuoli, keeps a bag packed by the door. Their memories stretch back to the Bradyseism crisis of the 1980s, when they were forced to leave for months. The youngest Andrea scrolls through videos of the bubbling sea on his phone, asking his grandmother if it was like this before. She shakes her head, remembering the fear, the suddenness, the way the ground seemed to move beneath their feet. "We lived through it once," she says quietly. "We hope not to again." Scientists and officials return to the same refrain. The signs are worrying, but no one can say with certainty what will happen next. The caldera is restless, the data is clear, but the future remains hidden. In Naples, people live with this ambiguity every day. The ground beneath their feet is alive, and every bubble, every tremor, is a reminder that certainty is a luxury this place has never known. In 2025, thermal cameras and gas sensors recorded several degree temperature spikes and high carbon dioxide and sulfur dioxide levels in the bubbling waters near Naples, confirming direct volcanic activity from Campi Flegrei. Historical records show that in 1538, similar unrest led to the sudden birth of Monte Nuovo, altering the coastline within days. Today, satellite data reveals the fastest ground uplift in decades. Earthquake swarms are becoming more frequent and shallow, and authorities have raised the alert level and tested emergency sirens across the region. Scientists agree these warning signs are converging, but no one can predict exactly when or if a major eruption will occur. While over 3 million people live above this restless caldera, the timeline for future activity remains uncertain. For now, the evidence demands constant monitoring and preparedness. The lessons of the past and the realities of the present leave no doubt. Campi Flegrei is far from quiet.